All right, let's move over now to 250.102. And I'm going to jump to 250.102C, supply side bonding jumpers. Now, we talked about the supply side bonding jumpers. If you have a single raceway, we'll probably have to add a graphic for this. The supply side bonding jumper is sized at table 250.66 based on the largest ungrounded conductor within the raceway. And we've had a bunch of supply side bonding jumpers along. Remember we had the service raceway and we had the bonding jumper in the service raceway? Well, that was the supply side. And if it was like 500 kc mills, and that one offset nipple, that'd be an example of a single raceway supply side bonding jumper. Go to table 250.66, and that's how you size the supply side bonding jumper. What happens if you have parallel? Let's take a look at this example. If you have parallel, here's a meter can, here's the supply side, here's the service disconnect, 1200 amps, here is going to be feeder conductors. Well, how do you supply the supply side for each of the raceways? Each service raceway contains 700 kc mil service conductors. The supply side bonding jumper, according to table 250.66, is going to be 2 watt. So that'd be 2 watts right here. The supply side bonding jumper, where routed with the parallel raceways, is sized based upon the largest ungrounded conductor in each raceway. So this is the rule, this is the condition, and that's the result. Scott?
Yeah, and one point to point out also is that if all of those are enclosed in one raceway, you could wind up with a situation looking back at table 250.66 where you go over the 1100 MCM, KC mil, where you sum all those parts. So in that case, the 12.5% rule comes into play.
So what I could do here is add a new graphic with a cable tray. Right?
Cable tray, trough,
but cable tray would be a little easier to visualize this and make it in a graphic form. If I had a cable tray with 3 sets of 700 kc mils, this is a service. And I'm going to run one supply side bonding jumper with the 3 sets of 700 kc mils. Then the calculation that would be involved in that is that 250.102C2 says that if it's over 1100 kc mils, then the supply side bonding jumper size is 12.5%. Now let's run the numbers through that we're working here.
Well, if where it gets a little crazy is, let's say if you have a large...
Now let's stick with one example, and then let's work the number through, and then we can go to another one.
Okay, all right.
So if we have 3 sets of 700 kc mils, that's going to give me 2100 kc mils. If you go over 1100 kc mils, the supply side bonding jumper is no longer used. You can't use the table anymore because you exceed the table. We got to go 12.5%. And 12.5%. Eric, you want to get
281.
Want to get your slide rule out there? Can you? You get your slide rule there, and so what is 12.5% of 2100 kc mils?
281.
He actually is using a slide
Eric
rule
is a
on that.
real engineer.
So therefore, if we show this cable tray example, right, Mike's right next to me here, he would have then showed the one supply side jumper that would have been 2100 times 0.125, which was 281,000 circular mils, and then of course we'd have to then put a 300 kc mil supply side bonded jumper. Now, unless we need to go another example, that one's okay?
That's good. I was just going to say, every once in a while, I did get this question one time. If I had 10 sets of 600s, 10 sets...
Well, 1 second. Hold on. This is not uncommon that you might have a large service.
Right. So you have 10 sets of 600,000.
We're not going to put those on a graphic, but let's go
Right.
with 10 sets
10
of
sets.
600,000. That gives you 6 million,
Right.
right? 12.5% of that.
Winds up with 750. So you actually wind up with a supply side bonding jumper that the single conductor at 750 kc mil is
It's
actually larger than any of the other conductors. And the answer is that's correct, because you're paralleling all those other conductors, so you can wind up with a larger conductor.
Okay, good. We got that one covered. I think we did a good job on that. Let's go on to the load side. I like it that we have the same graphic that we can show here. Here's the supply side bonding jumper. This is now going to be the load side bonding jumper. Equipment bonding jumpers on the load side of an overcurrent device must be sized based upon table 251.22. Size the table based on the circuit overcurrent protection device rating. Well, this was, we don't have that. Oh, here he is. It's a 1200 amp device. Go to table 251.22. The feeder bonding jumpers are sized to the overcurrent device rating. And so therefore, I'm assuming that's 3-aught. So each of these are 3-aught. I don't know if we have a graphic showing, okay, how do we size the equipment bonding jumper if we're going to use that's one for each raceway. We get the example of the other one. How do we size the equipment bonding jumper, guys? Ryan? If we have one equipment bonding jumper.
Just on the load side or the line side?
On the load side. Here
Same way.
Let's take a look at the
exact
graphic. 250.102D says that a single continuous equipment bonding jumper can connect in parallel when sized in accordance with 250.122 based on the size of the overcurrent device. So, a 3/0. You can put 1, 2, 3 3/0 or 1 3/0. And in our example back over here on the supply side, we could actually take this example here and not have to show another example, but where we could run 1, 2, 3 here, right? And that would have been your, instead of a cable tray, that would have been 777. That would have been 300,000.
300.
Right.
So that'd have been a 300,000, a single one, or 3 3/0. This one would be 3 2/0. This would be 3 3/0 or 1 3/0.
Right.
It would be kind of nice. Maybe Mike can use this graphic here to kind of put this together where we can show what this would be. What 300,000s. This is 3/0.
Right.
Or this is going to be, what was it, 2/0 and 3/0. That you good with that?
Yes.
Happy with that? I know that was something, Scott, you wanted to make sure we drove home. Steve.
It might be kind of interesting to look at that line side one again, Mike, and notice that when we size the grounding electrode conductor or the main bonding jumper, we use table 250.66 also, but we never, but just the ground electrode conductor, we never go use the 12.5%. It just stops when the table
The
maxes
grounding
out.
electric conductor goes in the table only.
Yeah.
We didn't talk about this, but you generally do not size the main bonding jumper because that's supplied by the manufacturer.
Yeah.
But if we did size the main bonding jumper, that'd be 250.28, and that would refer us back over to this. Well, let me go back to the server
12.5%
side.
thing. Yeah.
That would give us over to where you have a single one, and that would be our 12.5% if we
Yeah.
had to size this.
Right. Well, and sometimes you do size. Well, actually, a lot of times you size the system bonding jumper.
Yeah, system
the
bonding
same
jumper,
rule-
that's
same rule
separately drive
applies.
systems.
Right.
Yeah.
So you're saying if I got a large generator and I'm running 3 sets of 500 kC mills and I'm going to go to a 1200 amp disconnect, right? Well, or from the 1200 amp generator disconnect, what's the size system bonding jumper?
Right.
Well, you're going to have to go 3 sets of 700 kC mills. The system bonding jumper then is going to be 12.5% of 2100, and your slide rule said it was 281,000. So 300 kC mills is the system bonding jumper. So this rule 250.102 is real important because your system bonding jumper, your main bonding jumper, your grounding electroconductors, all those, oftentimes they reference you to 250.102, and then 250.102 is where it kind of contains in that 12.5%. If you get over, that doesn't apply to grounding electroconductors, but your system bonding jumpers and main bonding jumpers, it's going to take you to this table here, or to this section
And
here.
our grounded conductor.
Yeah,
And our grounding conductor also, it's for service, the service grounding conductor,
Yeah.
neutral, service neutral.
One of the easy ways to remember it is that table 250.66, if you look at the top, it says grounding electrode conductors. That's the only time the table is absolute. Every other time it's referred to for use in sizing other conductors, it will say the 12.5% rule applies.
But
So
you know
it's
what I think-
absolute for grounding electrode conductors.
I tell you what I think I'm going to do. I'm going to submit a proposal in 2014, and I'm going to take table 250.66, the content of it, and I'm going to put it in table in 250.102C. And anytime you are to size anything according to 102C, you go right to 250.102C. You never go to 250.66. And the reference to 250.66 would only apply when you only can use the table. You follow what I'm saying? Because there's no reason not to have all the requirements on system, supply side bonding jumpers and system bonding jumpers and 250.102C. There's no reason to say, okay, well, go to that, but then use this, because then that's when you get the confusion. There's nothing wrong with simply saying, here's your grounding electric conductor size, and you only use that table when what? The grounding electric conductor size. If you're going to size your ground and neutral service conductor, you're not going to go to 266. You're going to go to what? 250.102C. How do you size your system bonding jumper? 250.102C. How do you size your supply side bonding jumper? 250.102C, and you don't go anywhere else. It's like, okay, well, remember this table you use, but you only use up to this point in some cases. So we'll see if that works.
Yeah, it's been moved around a little bit. The way it's done now is the rules are in the individual section. And it's all kind of all inclusive in that individual section, which the idea there is to make it easier.
All right, let's move on. 250.102E. The basic rules equipment grounding conductors must be contained in the same raceway, trench, or cable tray with all other circuit conductors. There is a permission here. An external bonding jumper is permitted, or conductor, if it's routed with the raceway and it doesn't exceed 6 feet in length. So there's some applications where that just kind of makes sense. And here's an example where the fitting is designed for the equipment bonding jumper. And in some petrochemical industries, I've done some work for some petrochemical industries, and they want to see that bonding jumper on the outside. I said, why? Why don't you put it on the inside? They said, because we want to see it. I said, okay.